Sheikh Mubashir. Yes. So we'll continue the session. Yesterday we completed hubs, right? Hub and switches. Today we'll do routers, okay? Router function, and then we'll start IPv4. Okay. We'll start IPv4. Tomorrow subnetting. After completing the subnetting, Monday we'll do practical session. So switch functions we completed, right? Let's see guys here. Router functions. Okay guys. Heading routers. Router function. Router is an intelligent device. Router is an intelligent device. It will maintain routing table. It will maintain routing table. It will enable the third point. First point, router is an intelligent device. Second point, it will maintain routing table. Third point, it will enable the communication between two different logical networks. Fourth point, it will decide the best path to reach the destination. Simple one word answer, path determination. Got it guys? Path determination. So it will decide the best path to reach the destination. Right guys? So let's see here. So this is one network. This is another network. Those both are assumed as physical networks, legacy networks, right? Guys, if you establish the legacy network, it's not enough. If you establish the legacy network, it's not enough, guys, right? So we need to assign the logical addressing, IP addresses. Simple, guys. I need to communicate with you people. Maybe you are into your hometown. Then how I can able to communicate with you? With the help of mobile number, right? So using your contact number, so we can able to communicate, right? So how the like each and every person, they have the contact number, like the same way in our network, each and every mission should have one contact number. That is called IP addresses. That is called IP address, right? So IP addresses are logical network. So if we having physical network, it's not enough, right? We need to assign the logical network also. So 192.168.1.0, this is one logical network. This is another logical network. Two different logical networks will have. We need to enable the communication between those both the networks. In the sense, we need to use one device called router. Okay, this is router symbol. I'll show you a few images from internet. So how the router it will be looking, right? So let's see guys, router, Cisco router images. So this is not our home router, guys. Cisco router images. See guys. So right. So I think this is a best image. This is front view and it's a back view. This is front view and it's a back view, and router also having auxiliary port, console port, few NIC cards. Okay. Router definition. Router, it will enable the best, it will enable the communication between two different logical networks. That is a router definition. It will decide the route. That is what I have given the like 4 to 5 points. Got it? The main purpose of the router, why we need to use the router. Router is a device, right? Router device, what it will do? It will enable the communication between two different logical networks. So clear, guys? So this is router, guys. This is router device. So clear? Then how we have the computer, like the same way we'll have a device called router. How the computer it will work, like the same way we'll have the router device. We doesn't have keyboard, we doesn't have monitor. Computer, router, both are similar devices. Got it? Right. So let's see, guys, here. What it will do, it will enable the communication between two different logical networks. So if you directly try to sending the data from this network to this network to this network, we are unable to send the data because two different networks, right? So two different logical networks. We are unable to communicate with two different logical network directly. We need to use one device called router. It's a layer 3 device. It's a layer 3 device. So clear? So this device, it will enable the communication between those both the networks. And path determination. Right, guys? So first, it's an intelligent device. Why it is intelligent device in the sense? This router automatically, it will capture the neighbor's router's IP addresses. It will maintain into the routing table. So we have few concepts called dynamic routing. So in CCNA routing and switching, we'll have the dynamic routing concepts. So if you configure the dynamic routing concept, automatically neighbor's routing table, it is going to capture, it will maintain into routing table. Neighbors, IP addresses, neighbor router details, it will capture, it will maintain into the routing table, right? So I hope you got it, guys. So next point, it will enable the communication between two different logical network. So path determination, or you can say it will decide the best path to send the data. So guys, according to this diagram, how many routers will have? This round circles are routers, guys, okay? So 5 routers will have, right? So this is Hyderabad branch. Assume this Naresh IT having two different branches. This is Hyderabad branch and it's a Chennai branch, right? So this is Hyderabad branch network. Router it having switch, router it connected with switch. With the help of switches, we connected multiple machines here. This is total one network into our organization. And this is another network into Chennai branch, right? Now mission 1 from Hyderabad, he's tried to sending the data to mission 1 to Chennai. Got it, guys. Mission 1, it is try to sending the data to the switch. Switch, it is going to transfer the data to the router. This router, it will decide the best path to reach the destination. So which one is a best path according to this diagram? So above one or below one? So this is a best path, right? According to this diagram. So below one is a best path, right? So because here we'll have the only one router. Here we'll have only one router. Coming to here, 2 routers will have. Simple, guys. You are trying to traveling from Hyderabad to Chennai. Assume thus we have 2 different routes, right? Which route you are going to prefer? Shortest route. Like the same way here also. So this router, it will prefer shortest route. So according to this diagram, this is a shortest route to decide to send the data. Right, guys? How it will decide? So how the router it will decide? How this router it will decide the best path with the help of routing protocols. With the help of routing protocols, guys. So coming to routing protocols, RIP full form. So जो लोग आप सोच रहे वो नहीं है, right? So routing information protocol, right? And EIGRP, enhanced interior gateway routing protocol, and OSPF, open shortest path first. RIP full form. RIP stands for routing information protocol, right? So routing information protocol. For example, if you configure the RIP in this router, this RIP, it will decide this is the best path to reach the destination. RIP, it will work depend on your hop count. Hop means router. So this side, this way we'll have two routers. This way we'll have only one router. RIP, it will decide this is the best path to reach the destination. Got it, guys? So now from CCNA, routing and switching V3 onwards, people, they are not teaching RIP. Right. So we are using EAGRP and OSPF. EAGRP stands for Enhanced Interior Gateway Routing Protocol. Right. So if you configure the EAGRP into this router, it will decide the best path with bandwidth. For example, this side will have 100 Mbps bandwidth. This side will have 1000 Mbps bandwidth. Now EIGRP will decide this is the best path to reach the destination. Depends upon bandwidth, it will decide the best path to reach the destination. OSPF, Open Shortest Path First. This is a successor of RIP. Got it, guys? It's a successor of RIP. OSPF, it's a successor of RIP. Guys, we are unable to configure the multiple protocols. We need to configure only one. It may be RIP, it may be EIGRP, it may be OSPF. Right? Need one protocol we need to configure. This protocol, it will decide the best path. It will send the data to destination. This router, it will send the data to the missions. So how it is going to send the data to mission? With the help of routed protocols. Routing protocols, routed protocols. So routed protocols, example, IP addresses, IP, IPX, AppleTag. So IP, general computers. So normal IPX, IBM, AppleTag, Apple computers. So most of the people, even like IBM and Apple also, nowadays we're using IP addresses only, IPs only. Internet protocol. Okay. So with the help of IP, we are going to send the data between the missions. So with the help of IP addresses, we are going to share the data. So we are not going to share the data. So the switch and router, it is going to share the data between the missions with the help of routed protocols. So this is called path determination. I hope you got it, guys. Yes, no? Good. So this is all about network devices, guys. At least we need to use one network device to establish the network into our organization, right? Next, IP addresses. Now we'll discuss about IP addresses, right? Guys, IP addresses concepts are very, very important, please. Right, guys. Okay. IP addresses. Guys, coming to IPs, we'll have two types of versions, IPv4 and IPv6, right? IPv4 and IPv6. Sir, those classes is already taken. What happened? Sayyid Jamaluddin, you belongs to AWS, my batch. Yes, Jamaluddin. So for Avinash sir also, I hope like you know very well about networking, because for those all the concept I have taken for you for 10 days. Okay, no issues. Yes, Apart from Avinash sir class, apart from my class. So reminding people, you need to focus. Avinash sir class peoples also, they know very well about IP addresses and those all. Okay. So clear, guys. Right. So we'll have Srikanth sir peoples and we'll have Funny sir peoples, right? Funny sir students and Srikanth sir students will have. For them, we need to teach, right? Huh? Yes, no. Only Imran sir, Avinash sir peoples, they know about networking. Huh? And what about remaining sir? Pavan Kumar, you are my student? Huh? Yes, you are all my students only, man. Okay, good. So clear? Okay, right. So let it continue the session. So who know it's good, who doesn't know, for them it's very good, right? Already Avinash sir, students, they know about networking because we discussed for 10 days. Huh? Okay, guys. Morning session, right? Very good. Okay, so let's see, guys, here. IPv4, IPv6, two types of versions we'll have in IP addresses. First of all, why we need IP addresses? Already I have given the information before. IP address, it's like your contact number. So each and every person, they have the physical address as well as logical address. Logical address, right? Physical address means your postal address, guys. Coming to computer, physical address means MAC address. MAC address, media access control address. Logical address means IP addresses in computers. So coming to person, contact number is a logical address. Logically, we can able to communicate with him using your mobile number. So mobile numbers are unique, right? Mobile numbers are unique. We doesn't have the same mobile number for multiple peoples. So they are going to provide unique contact number for us. Like the same way, coming to in our network, IP address is also unique. We are unable to provide the same IP address for multiple machines. Okay. IP addresses are unique addresses. I hope you got it, guys. Okay. So coming to IP addresses, we have two versions, IPv4 and IPv6. IPv4 and IPv6, right? So coming to IPv4, it's a 32-bit addressing. Coming to IPv4, it's a 32-bit addressing. So 2 to the power of 32 is a formula for knowing the combinations of IPv4. To know the combinations, how many combinations we'll have in IPv4, how we can able to know 2 to the power of 32. 2 to the power of 32. So how many combinations we'll have? More than 4 billion combinations we'll have. I hope you got it, guys. Clear? So those many combinations we'll have. Those all the combinations we utilized. We doesn't have the any combination in IPv4 nowadays. So IPv4 IP addresses, it got over, completed. Without IP address, can we able to communicate from one device to another device? Nowadays, most of the people, they are using smart mobiles, smart devices. Right, guys? Each and every smart device, each and every smart mobiles, it having one IP address to communicate from one device to another device. For example, we have smart CC cam. Right, guys? We have smart CC cam. So how you are trying to communicating with your smart CC cam? With the help of your mobile. Mobile having one IP address, that smart CC cam device having one IP address. We need to connect the smart CC cam device with Wi-Fi, maybe with internet into our home. Automatically Wi-Fi and then internet connectivity will provide one IP address for this device. With the help of the device, we can able to communicate with the smart CC cam with the help of your mobile. So you can download few applications according to like your requirement. We will have few application related to smart CC cam mobile. When you can download it, we can able to communicate. So how we are trying to communicating with the help of IP addresses. Mobile device having one IP address, smart CC cam device also having one IP address. With the help of those both the IP addresses, we are going to communicate from one device to another device. Like this, n number of the people, n number of the smart devices they are utilizing now. I hope you got it, guys. Right? So we are using n number of the smart devices. So because of that reason, IPv4 range it got completed. So we doesn't have the IPv4 range nowadays, right? So we need to use smart devices in sense we need more IP addresses. So because of that reason, who introduced to us IP addresses and those all stuff? INA, very good. So INA or ICANN. ICANN people, they introduced to us IPv6, IP version 6, right guys? This is 128-bit addressing, 128-bit addressing. Why 128? Why not 64? Why not more than 128? Exactly why they introduced to us IPv6 as a 128-bit. Why not 64? Why not more than 128? So if they introduce to a 64-bit, maybe in future we are going to get some problem, IP address shortage problem. Because of that reason, they introduced to us 128. Why not more than 128? Because our devices, it will support till 128. More than 128, it won't support. Because of that reason, INA people, they introduced to us IPv6 as a 128-bit. I hope you got it, guys, right? So 128-bit means compared to IPv4, we'll have 4 times IP addresses here. 4 times more IP addresses will have in IPv6 compared to IPv4. Who introduced to us those old stuff? Yes. From where you are getting internet, guys? Huh? Who's providing the internet connection to you? ISP. How ISP he is getting the internet connection? Huh? Yes. How ISPs they're getting internet connection? From where they're getting internet connection? Huh? ICA and then what happened, guys? LED jump. So guys, give me 1 minute online. Give me 1 minute. Guys, give me 1 minute because here some problem with LED. There's LED issue here and offline. So please give me 1 minute. Online, don't log out. Okay, I'm going to log out now because of some technical issue, right? So give me some time, 10 minutes, 10 minutes time, then I'm going to re-log in again. Dharani, ఎవరో ధరణి అంట ఇంకొకరు ధరణి. So Dharani, actually we have some technical issue here, so please try to support us. Okay, so give me 5 to 10 minutes time. I'm going to re-log in again. Log out, guys, don't log out. Okay, so I'm going to rejoin again. Okay, okay, online, can you hear me? Am I audible? Right, good.